All right, so thank you everyone for listening in today on our update for the USGS Forage Fish 2025 surveys. Before I get started, I just want to acknowledge all the co-authors on this talk for helping get the data together to present to you today. An overall outline for today's talk, we'll start with a summary of the 2025 forage fish efforts, and that includes our hydroacoustic survey as well as the fall bottom trawl. Then we'll walk through some of the results from the 2025 surveys and our planned 2026 field season. All right, to start off, in August, we completed the hydroacoustic survey. That was 26 transects over 470 kilometers, shown here in yellow on the figure. This was a collaborative effort, as it is every year, between USGS, MDNR, and USFWS. It was also paired with 44 midwater tows, shown here in green, to give estimates of species composition and length, and it occurred over depths from 5 to 259 meters in the lake. We collected 397 alewife for aging over the course of this survey, and 374 of those were aged successfully. Moving into September, we completed the fall forage assessment using our bottom trawl, and this consisted of 76 tows, shown here in blue on the map. This was conducted entirely by the USGS from September 7th to the 19th, from depths of 5 meters to 128 meters. Alewife were collected for aging, a total of 398, and 385 were aged successfully. And this actually represents the highest number since 1988 that were aged from the bottom trawl. All right, so we're going to jump into results. I'll talk about the 3 species that are indexed in both surveys, alewife, bloater, and rainbow smelt. Then we'll talk about a few of the benthic species from the bottom trawl before talking about overall prey fish biomass from each survey. So starting off with alewife. First looking at what we call yearling and older fish. So these are fish that are equal to or greater than 100 millimeters in length. And here we have the catches from the acoustic and bottom trawl surveys, just represented over the lake. So the first thing to note is we had relatively good distribution of alewife catch throughout the lake. The acoustic survey saw the northwest as the highest densities, though we did have some high catches in the southeast as well. I think the highest density catch there was 94 kilograms per hectare, or estimate, not catch. For the fall bottom trawl, the first thing to note is the difference in scale between the 2 maps. So the highest density catch there was 9.4 kilograms per hectare, so an order of magnitude lower. Our greatest catches were north near Manistee and in the west near Port Washington. So we see these differences, order of magnitude difference in catch between the surveys, and that translates into our yearly biomass estimate from each survey. So the total biomass density estimate from the acoustic survey was 4.4 kilograms per hectare, and from the bottom trawl, 0.45. Here we've got the time series for each of these surveys. The bottom trawl starting in 1973, shown in black, and the acoustic survey shown in blue, starting in 2004. So if we look at this year's numbers compared to previous seasons, the first thing to note is they are obviously far below some of the estimates in 70s and 80s and 90s. However, if we look at the acoustic survey, we see the value was relatively similar to last year and was actually the 4th largest value from that survey since 2004. The bottom trawl survey, again, was quite low, but very similar to the last 2 seasons. And we still see this discrepancy in numbers between the 2 surveys, with the bottom trawl being much lower. We think that's likely related to a change in habitat use or catchability of alewife within that survey. So we can see from this figure that we see some of that stability in the hydroacoustic survey over the last few years with similar numbers. It's a little more difficult to see with the bottom trawl, but if we zoom in on the period starting in 2016, we can see that in the last 5 years, we had about half a kilogram per hectare on average across the bottom trawl survey. In the previous 5 years, it was only 0.13 kilograms per hectare. Very few large fish were caught in that survey, and often our confidence intervals went over 0 in terms of overall biomass. So while it's very low, it seems to be relatively stable from the bottom trawl estimate over the last 5 years. Next, we'll look at age 0 catch from the acoustic survey for alewife. In 2025, we had 295 fish per hectare estimated from the acoustic survey. These are again well distributed throughout the lake, with high catches outside of Sturgeon Bay on the northwest and in the southern Main Basin. This estimate of 295 H0 alewife per hectare is actually lower than average and lower than the estimate from the last 2 years. So some evidence of a potentially weaker year class. When we look at overall alewife age structure, we've got log density at age on the left versus age, and then proportion at age on the figure on the right. A few things can pop out. First, that for the acoustic survey, which is shown in blue, across ages, we see that higher density estimate. So this is an effect that's occurring across all ages of alewife in the lake. We also see a relatively low catch of age 1 fish. Now, this isn't necessarily surprising from the bottom trawl. We know that that tends to underestimate that particular age class. However, we see that in the hydroacoustic survey as well. So there might be some evidence that even last year's recruitment was relatively weak, and potentially we had a weak year class in 2024. When we look at the proportion at age, we see that most fish in both surveys were either age 0 or age 2. And in fact, that age 2 class likely represents a relatively strong year class that Ben alluded to in his talk from 2023. I'll also note that only 5% of fish were age 4 or older. So again, coming back to Ben's talk, we don't see many large fish in the lake, potentially representing age truncation in the population. All right, moving on from alewife, we're going to focus on the next species sampled in both surveys, which is bloater. So for large bloater, or those greater than 120 millimeters, catch again was relatively well distributed across the lake. The highest catches for the acoustic survey occurred in the south, close to 50 kilograms per hectare. In the bottom trawl, they were close to 20 kilograms per hectare and were largely in the north, although again, numbers were pretty well distributed. Translating that into our yearly biomass estimate for the acoustic survey, we had 3.5 kilograms per hectare, and the bottom trawl, 1.9. Looking at those numbers across the entire time series, you can clearly see that they are nowhere near the levels that we saw in the 80s and 90s when bloater biomass was exploding on Lake Michigan. However, if we look at just the time period where we have both surveys starting in 2004, we see sort of a different story. So again, the blue is the acoustic survey, and you can see that around 2010, it went from very low values to increasing really over the last 15 years. And there might still be an increasing trend with some stabilization in this 2025 season. For the bottom trawl, we see something similar. You're coming off that big peak up until 2012, where it kind of gets very low, and then you start to see that increase again. So it's just showing some accumulation of bloater biomass in the lake over the last 15 years. Looking at small bloater, or those less than 120 millimeters, which can be used as an index of recruitment. We see in the acoustic survey, we had the highest catches in the south, really in deeper waters, approaching 8,000 fish per hectare. From the bottom trawl, we saw far fewer. The highest catches were in the northwest and southeast, but really less than 200 fish per hectare in any given trawl. And we can see these values translate into our annual estimates. So for the acoustic survey, it was 540 small bloater per hectare, while the bottom trawl was only 6.1. Now, a few things of note. This is the second year in a row where we saw high numbers of bloater, age 0 or small bloater, I should say, from the acoustic survey. But we continue to see this discrepancy with the bottom trawl. Interestingly enough, on Lake Huron, they also had evidence of a high recruitment event for bloater in 2025. So it seems like there could be some increased evidence of that. Moving on to the last species indexed by both surveys, rainbow smelt, and starting with large rainbow smelt greater than 90 millimeters. In the acoustic survey, we saw the highest densities in the north, as well as south of Saugatuck on a single transect where densities were high. The highest catches were close to 20 kilograms per hectare. In the bottom trawl, it was a different story. We didn't have a catch that was over 2 kilograms per hectare, and most of those fish were caught in the central portion of the lake. Looking at the overall time series relative to our 2025 estimates, we had 0.69 kilograms per hectare from the acoustic survey and 0.04 kilograms per hectare for the bottom trawl. So this number from the acoustic survey was actually the highest since 2007. So we did see this slight uptick in rainbow smelt densities However, relative to historic numbers, very low. We've seen this kind of number before in recent years. In 2016, the value was close to that as well, and then kind of dipped back down. So we're interested to see where this goes moving forward. Looking at small rainbow smelt, we actually had really high catches in the acoustic survey, and the highest occurring right there in the central portion of the lake, close to 11,000 fish per hectare. In the bottom trawl, numbers were an order of magnitude smaller, but still 1,600 fish per hectare were collected right outside of Ludington. So that central portion of the lake continues to see some pretty good densities of rainbow smelt. And what's really interesting is when you look at the annual estimates for the small rainbow smelt, potentially, again, indicative of a recruitment event, it's 541 fish per hectare in the acoustic survey, which is actually quite similar to the bloater numbers, and 41 fish per hectare in the bottom trawl. So again, thinking about this in the context of Lake Huron, we actually saw high numbers of rainbow smelt, small rainbow smelt in the acoustic and bottom trawl in Lake Huron as well. So again, multiple lakes showing potential recruitment events. All right, so I'm going to move on to a few species that are indexed simply from the bottom trawl survey. We'll start with two stickleback species, the 9-spine and 3-spine. I don't usually talk about these much in these talks, but it was sort of an interesting year. We saw pretty high values for both species. For 9-spine, we had 0.2 kilograms per hectare, which is the highest value since 2006. And 3-spine, it was around 0.05 kilograms per hectare. Huge error bars, but notable, given that it was actually the highest density we saw overall. The mechanism causing these increases is slightly unclear. However, it's interesting to note that on Lake Superior, they also saw high numbers of both of these species. And in Grand Traverse Bay, where there's an independent survey of a transect bottom trawl survey, they saw extremely high numbers of brook stickleback. So we're not sure exactly what's happening with stickleback right now on Lake Michigan. One thought is this could be some sort of a predation buffer effect. So there could be slightly more alewife, bloater in the system, causing some release of these species. In Lake Superior, this could be related to a really strong 2022 year class of carrigidines, potentially providing some room for these species to increase. It's also possible it could be the result of some climate forcing events, although the mechanism is unclear there, or it could be random chance. So we're sort of interested to see how this plays out in the next few years. All right, moving on to overall forage fish biomass, we'll start with the bottom trawl survey, and then we'll move into the acoustic. Over the time series, we've indexed 7 species that are included in this fall bottom trawl biomass estimate, 4 of which we've already spoken about today, as well as deep water sculpin, slimy sculpin, and round goby. So the overall biomass estimate this year was 3.4 kilograms per hectare, which is clearly much lower than we've had historically in the survey through the around 2010 period of time. But it's actually very similar to what we've seen since 2016. So again, we're seeing this relatively low and stable estimate coming out of the fall bottom trawl survey. I haven't talked about these other species specifically today, but I'll just note that deep water and slimy sculpin remain at historic lows and have for the last decade and a half. And goby was around 0.5 kilogram per hectare, so quite low. Moving on to the acoustic survey, we based this forage biomass density on 3 species, rainbow smelt, bloater, and alewife. And the total value there was 9.3 kilograms per hectare, which is actually very similar to what we've seen for the last 3 seasons, and is the 3rd highest on record during the standardized survey since 2004. And that was mostly contributions from bloater and alewife. I would note we've included some previous surveys from the 80s and 90s from a different survey design for the acoustic survey, but it just shows that even with these higher values in the last 3 years, it's still quite a bit lower than some of those higher values that mirror what we see in the bottom trawl survey in the past. So overall, I think a few key messages come out from the surveys this year. Our biomass estimates were relatively similar from 2024 across the 2 surveys. We had some evidence of high recruitment events for both bloater and rainbow smelt in the lake. Recruitment of alewife was relatively low based on an age 0 index, and we're still seeing an age-, truncated, 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 age-, trun Moving on to our 2026 plans. The annual report will be finalized in late May, so it's slightly delayed, but there is a copy out front here. So if you'd like to get that hard copy, you can look through the results we presented today, as well as some additional information. The predator-prey ratio data will be delivered by April 1st, so we'll have those information ready for management decision-making. We plan to complete the annual acoustic and bottom trawl surveys in their entirety in 2026, and we will be completing some CSMI 2025 work that was postponed due to funding delays to 2026. This includes some work by Peter Esselman, my colleague at the USGS, on advanced tech, focusing on round govie overwintering ecology and whitefish egg predation, as well as some mapping of priority reefs within Lake Michigan. And I'll be leading another effort focusing on weekly sampling for larval alewife and perch with a large group of collaborators around the lake to look at differences in growth and diet across the system. And with that, I'll just say thank you to you for listening in today, as well as our technician team and our large vessel staff for completing this work and getting it ready for today's talk. So thank you.